Okay students, in this particular class what we are going to do is we are going to solve some more numericals based on equilibrium conditions. Okay, so in the previous video I had taken one numerical. In this particular we are going to see a little bit different here. Okay, first I will read out the question. Let's see what is the question. There is the L-shaped member ACB is supported by a pin support at point C. We'll see the diagram later. Okay, and when inextensible cord attached at point A and B and passing over a frictionless pulley at point D, determine the tension in the cord and the reaction at C. So he is asking to find the tension in the cord and also find the reaction at point C. Okay, this is the diagram what he has given. So let's see, this is the L-shaped member A, C, B, which is supported by a pin support at point C. This is the point C and this is pin joint. Okay, by an inextensible cord attached at A and B. So that means this is the inextensible cord, the wire cord like that. It is inextensible cord. Okay, so this inextensible cord is attached at point B and A and passing over a frictionless pulley. So this is the frictionless pulley. This particular cord is going like this. It is passing over the pulley and it is joining point A. So this read the question very carefully because so many points will be there in the question itself. Okay, because he is telling the frictionless pulley. So that means it is saying something. That one we'll see while solving the numericals. Determine the tension in the cord and the reaction at C. Okay, let's start solving the problem. So you know the first step. The first step is free body diagram. So step 1, free body diagram. So you know what is free body diagram. So what I'm going to do is I'll write down all the different forces, whether it is active force or reactive forces. I'm going to show in the free body diagram. So I have taken this L-shaped member. So since it is a pin joint, there are two forces will be acting. One is horizontal force and another one is vertical force. So which I am showing in the HC, that is horizontal force, and VC, which is in the vertical force. And I am taking HC in the right direction, which is going, the force is going in the right direction, and the vertical force C is going in the upward direction. This is you can take in the opposite direction also, but only thing is you have to assume the direction. So if your assumed direction is right, then you will get the positive answer. If your assumed direction is wrong, then you will get the negative answer. The magnitude will be same, only the direction will change. Okay, since you can see there is a frictionless pulley, so that means whatever the tension is there is no क्या बोलते हैं, वेस्ट नहीं हो रहा है, कुछ भी लॉसेस नहीं हो रहा है, फोर्सेस में चेंजेस नहीं हो रहा. पुली अगर फ्रिक्शन रहता तो देयर मे बी चांसेस इन द changes in the volume of the forces at the point B and at point A. Since the pulley is frictionless, there is no any loss of forces or energy. So that's why this is this force tension. So always you know tension force is acting away from the member. The member is this one, this pressure member. So you have to, there is a one tension force like this, which I have shown like this, tension BD, and another force tension AD. So I have shown this. Actually both TBD and TAD is equal to are both the same, both same. So that's why I written here TAD is equal to TBD is equal to tension. Okay, that is we can mention T, and there is 110 Newton vertical force acting at this location, which is given. So this is the FBD. You can see there is a HC force, VC force, there is a tension force TBD and TAD, which are both are same. There is 110 Newton, and we have shown all the 300 mm, 400 mm, whatever the dimensions which is given in the numerical itself. Okay, so this is the FBD. See, by seeing the diagram, what he is asking is find the tension in the cord. That is, you need to find TBD and TAD. That means you need to find the tension T. Second one is find the reaction at C. That means there is HC and VC. So you need to find out the resultant of that one. Reaction at C means you need to find the resultant force which is acting at point C. So, okay. So the question is, you see the properly the FBD diagram. So by seeing the different types of forces. There are 1, 2, 3, 4, 5 forces are there. You need to check whether this force system is coplanar concurrent or coplanar non-concurrent force system, because whatever the equations you are going to take for solving the problems, that depends, the number of equations depends upon the force system. So by saying this diagram, this is coplanar non-concurrent force system, because all the forces are acting at different locations. Concurrent force system means all the forces are acting and passing through the same point, but in this direction different point locations where there are forces are acting, that's why it is coplanar non-concurrent forces. So that means there are, for non-concurrent force system, there are 3 equilibrium conditions: summation fx is equal to 0, summation fy is equal to 0, and summation of moment is equal to 0. So these are the 3 conditions. By using these 3 conditions, we will find out the whatever the unknowns are. Okay? And one more important point is you need to give the sign convention. See, for what I am going to take is upward force and right side force I am going to consider as positive, downward and left side force I am going to consider as negative force, and clockwise I am going to consider as, if the force is acting clockwise direction, then it is considered as positive, and if it is anti-clockwise force, then I am going to consider as negative force. So these are the few forces I am going to consider. Okay? So first, starting, that is step 2, I am going to take moment about moments से start करता हूँ. I am not going for summation fx and summation fy. See, you can go that one, because why I am not going is, say if I go to summation fx, that is summation fx means all the forces which are acting in the horizontal direction. So if you see this diagram, there are 2 horizontal forces, xc and t. So you don't know xc, you don't know t. So that means you will not get the you are not going to find out any answers, unknown values. So that's why what I am going to do is, first I am going with the moment step. Okay? So step 2, you can take anywhere moment. I am taking moment about c. So summation of moments about point c is equal to 0. Since it is an equilibrium problem, you need to equate everything to 0. Okay, you know how to take the moment. You will have to take all the forces and do the moment. So since the moment center is about this point C, xc is passing through C, so this force is gone. Vc is passing through C, this force is gone. All these concepts you already studied in the first unit itself. Okay? So now remaining forces are TAD, 110 Newton, and TVD. Clear? So TAD and TVD is nothing but T. Okay, these 3 forces we are going to write the moment. Okay, first T into 300. So first I am going to take TBD. So this force TBD, moment is nothing but force into perpendicular distance. So this is the force TBD into perpendicular distance. That means the distance between perpendicular distance between the force and the moment center. So this is the perpendicular distance. How much it is? 300 mm. So T into 300. So now question is whether it is in the clockwise direction or anti-clockwise direction. So since it is in the clockwise direction, so you can see there is moment center here. This is the force. So if you fix this moment center, this force is, arrow mark is going in the right direction. So it will rotate like this. So that means this is clockwise direction. The sign convention is positive. That's why I have taken positive T into 300. Okay, I will come to second force, that is 110 Newton. So once the moment center is this one, this is 110 Newton, which is acting downward direction. If you fix this finger and you rotate this one, so it is rotating clockwise direction. 110 into, this is the perpendicular distance, 400. So that's why, since it is clockwise direction, I have taken positive. The next force is TAD. So once again moment center is C, this is TAD, which is going in the above upward direction. So you will rotate like this, it is going on anti-clockwise direction. That's why minus TAD into 400. Okay, so this is 300T, this is 110 into 400 is 44,000. This is T into 400 is minus 400T. So if you solve this equation, you will get T is equal to 440 Newton. Okay, so this becomes, you got the one unknown tension. So you know T is nothing but TAD, TBD, both values are same. That's what. Now we'll go on to step 3, where step 3 is equal to, we will find out summation fx and summation fy. So So summation Fx is equal to 0. All the x components should be equal to 0. Let's see what are the x components, that is horizontal forces Hc. So I have written Hc. Since it is going on the right side, so I have taken positive because my sign convention for right side is positive. The second this one is T be there. So that is T. This is positive. Once again right side positive. T plus Hc is equal to 0, and you know the T value. Therefore Hc is equal to minus 440 Newton, or Hc is equal to 440 Newton, since minus it is left side. So that means, see, Hc you have taken right side, but you are getting minus 440 Newton. So that means whatever the direction you have taken, it is wrong. You need to take the left side. Okay, that's why I am showing Hc is 440 Newton, but assume direction is wrong. So you need to, instead of right side, it has to be the left side. Okay. Step 3. Sorry, step 3 again. Step 4. Summation Fy is equal to 0. Summation Fy is equal to 0. All the y components should be equal to 0. कौन सा है y components? BCA, 110 है, TAD है. There are 3 R's है. So BC ऊपर जा रहा है तो BC, TAD, so that is T ऊपर जा रहा है plus T. 110 Newton नीचे आ रहा है, then that is minus 110, that is equal to 0. So that means VC plus T is minus 110 is equal to 0. You know the T value, substitute the T value. Once again you do the calculation. VC for plus 440 minus 110, it is minus 330. So VC is equal to 330 Newton. Since minus का, I remove that minus and I show the downward direction. So minus indicates negative value. So once again, whatever the VC was taken upward direction, the direction is wrong. It has to be downward direction. Okay? So VC is equal to 330 Newton minus 330 Newton, or 330 downward direction. So now you got to know HC, you got to know VC. He is asking reaction at point C. So that means what is the resultant at particular point C. So to find the reaction or resultant of the force, you know very simple formula. You need to find the magnitude and direction. So step 5, that is reaction at point C, that is RC, is equal to under root of HC square plus BC square. HC value is 440 square, BC value is 330 square. So you do the calculation. RC is equal to 550 Newton. So this means this is the resultant, or this is the reaction at point C. So you got the magnitude, but what is the direction? That means what direction पे कौन सा angle पे वो force act हो रहा है point C पे. Because of HC and BC, there is a reaction force, a single force, a resultant force which is acting at point C. But कौन सा direction में वो बैठा है, वो ऐसा बैठा है या ऐसा है या मतलब what is the angle? So for that one, you need to find step 6, that is direction, that is theta. So you know the formula. Theta is equal to, your tan theta is equal to mode of BC divided by HC, vertical force divided by horizontal force. Theta is equal to tan inverse of BC by HC. Tan inverse of BC value is 330 Newton, 330, and the SC value is 440 Newton. So theta is equal to tan inverse of 0.75, or theta is equal to 36.87. So that means theta is equal to 36.87 degree with respect to x-axis. So that means the force which is acting 36, this is the, no need to show the theta. So but only thing is, this is the reaction force at point C, which is making 36.87 degree with respect to x-axis. So he asked two things: determine the tension in the rod, which you found out T is equal to 440 Newton, and he asked about the reaction at point C, at this point C. So you got reaction at point C, magnitude is 550 Newton, and theta is equal to 36.87 degree. Okay? So it's very simple numerical. Previous problem was about only Lami's theorem, and this problem it shows even you need to do the moment also, because it is a coplanar non-concurrent force.